Hello friends, in this video we shall study about big O notations. We will discuss about what is big O notation, why it is important to understand big O notation, what are the concepts of big O notation and what are the famous big O notations. What is big O notation? It is a notation that allows to express the performance or complexity of algorithms in relation to their input. It denotes about the execution time required, space used, etc. for performing a given task. In simple words, the Beggar notation is the most commonly used notation to measure the performance of any algorithm by defining its order of growth. For example, if we have two different algorithms to solve the same problem, where one algorithm executes in 10 iterations and the other in 20 iterations, the difference between two algorithms is not much. But if the first algorithm executes 10 iterations and the second executed 1000 iterations, then there is a matter of big concern. Here, bigger specifically describes about worst case scenario. As the name indicates, in big O notation, O represents order of and is concerned with what happens for very large values of n. Why understand big O notation? So one should understand big O notation to be able to program with best containers for storing data, to select best containers for solving a given problem. With also to be able to program with the best performance to be able to choose the best algorithms, to design quality software products, to be able to predict the time and space complexity based on given conditions. For all this, one should understand what is big O notation so that it is easy for him to choose one of the algorithms or the containers for the program. Big O helps determining complexity of an algorithm. Specifically here, we are interested in the worst case scenario. But big O can be used to determine best and expected case too. But this is not common. Here we are interested in the only worst case scenario. Even if basic understanding of big O notations helps in algorithm optimization a lot. Most of the software developers uses these principle without even knowing this. Big O specifically describes about worst case scenario. The main rule here is that big O deals with the dominant tail. That is, in the given expression n square plus 3n plus 4, this expression evaluates to a value which is approximately equal to n square, especially when n is very large. That is, if n is 1000, then 1000 square plus 3 into 1000 plus 4 is approximately considered as 1000 square itself. Also, in Big O, the constant coefficients of higher order terms are neglected. That is considered example n plus n equal to 3n. Here, this 3n is also approximately equal to n when n is infinity. That is, when huge values for huge values of n, this 3n is approximately equal to n. That is 3 times infinity is also infinity. Suppose an algorithm had to check whether an item is represented in an input array. So the program shall start checking each item in the array. If the item is found, the program will stop further checking and return. Here the best case is when the item is identified as the first item of array. Whereas the worst case is when the item is not found in the array or found as the last item of the array. In big O notation, the focus is on worst case. So we are interested on time or space complexity when item is not found or item is in the last array. That is, with big O, we know the worst possible scenario of our program. So these are the big O complexity chart. This chart represents some of the most commonly used big O notation and its efficiency. Most of the algorithms or data structures falls among one of these categories. In this video, we will study about these big O notations in time complexity only. That is, we are not covering about the space complexity here. O1. O1 is the most excellent complexity a program can have. Here the time complexity is constant regardless of how much time or how much items are present in this collection. This is the case when we have to obtain the first element from a set of data, or when we get element in the first time itself, that is like in hash table. In this case, the running time is independent of the input size. Consider the trend. Say time taken to access one item is x. When total item present is 10, then also time taken to access a single item shall be constant, that is x itself. Or if there is 1000 items present, then also the time taken to access one of the 1000 item is x. Such a trend is represented as time complexity of O of 1. Let's see one real world scenario. Assume that in a kitchen there are 25 chicken eggs available and there is only one fry pan. Our task is to cook a single omelette. We know that no matter which of the 25 egg is used, it will take constant time for cooking a single omelette. We only need to deal with one egg even if there are hundreds of eggs available in fridge. That is, the cooking time is independent of the number of eggs available. Thus, the scenario is having constant time complexity of O of 1 and it can be represented as O of 1. Let's say a C++ example. Here, we have to get the nth element from an array. So the function get nth element of array shall return the nth element in array with the time complexity of O of 1, no matter whatever the size of the array. In C++, STL containers like stdarray, hash table, the lookup have O of 1 time complexity. Thus, if your program is performing too much lookups, consider choosing one of these containers. Of course, when using this, you have to consider complexities of other operations you need to perform with the data structure. Some of the examples of O1 operations are accessing array index, inserting a node in linked list, pushing and popping on stack, inserting and removal from queue. Now let's see about O log 1. O log n means that the running time grows in proportion to the logarithmic of the input size. That is, consider the below trend. If 10 items take time x, 100 items take time 2x, then 10,000 items take time 4x. Such a trend have a logarithmic complexity O of log n. Let's see one real world scenario. We have to search for a word meaning from a dictionary. Normally, what we do is we open a random page of dictionary. If the open page has higher letter than the first letter of the search word, we will open random page to its left side. Otherwise, we will open a random page to its right. And we will continue this opening pages until we find the word we are searching for. Here, each time when we selected a page, an entire portion is skipped from search. That is, for example, if we are searching towards the left side, a complete right side portion is ignored. So this kind of search is called logarithmic search. Let's say programming example of using search in a binary tree. Here, our task is to search for an integer number 28 in binary tree. As you know, in binary tree search, first it checks the root node and identifies the new search path where the item has to be searched. Here in this example, we are searching for number 28. So the search path is identified as right side of root node with the value 20. So it completely removed the left tree from the search, reducing the items to search by half again. Again, it checks the next node and finds that 28 is towards the left side of 35. Here a complete right half for node 35 is discarded from search. It then identifies that value 28 is higher than 25. So the search moves to right side of the node 25. Now the search finds target value 28. Here as it is shown, the search is completed within 3 steps. This is an example of logarithmic search of time complexity O of log n. Thus in O log n, if n is the array size, it takes log n iteration to complete the operation. Some of the examples of O of log n algorithms are binary search, calculating Fibonacci number, etc. Often. In often, the complexity is linear. That is, it has linear time complexity. That is, larger the number of items, the more the running time. The complexity grows in proportional to the size of the problem here. That is, if the input size is double, then running time will also be double. Consider this trend. Say one item takes time x, two items is going to take time 2x. Also, four items take time 4x. Then nth item shall take time n into x. Such a progression have time complexity of n. Let's see one real world scenario. The scenario is customers waiting in a queue in a store's billing counter to pay for the items they have collected from store. For time being, let's assume that it takes only 5 minutes maximum time for a store employee to complete one billing. Also assume that there are only 5 customers in the queue at this time. So if we calculate the time a customer to complete billing, we can see that first customer take 5 minutes. Second customers take 10 minutes as he need to wait for first customer's billing to be over and then wait for the store employee to complete the billing process. Likewise, the customer at fifth position has to wait for 5 into 5 minutes, that is 25 minutes in total in this queue. Such a time progression have time complexity of O of n. Let's see a programming example. Here, we have written a function sum of array elements to find the sum of all elements in the array. For this, the program has a for loop that iterates through each element of the array and sum up the values. The linear time complexity of such a single for loop can be represented as O of n. That is, if n is the array size, then it takes n iteration to complete the operation. If array size is 1 million, then there will be 1 million iterations. Here the performance is inversely proportional to size. Some of the examples of O of n are traversing an array, traversing a linked list, linear search, comparing two strings, checking for final palindrome, etc. O of n square. In O of n square, the time complexity is quadratic. Here number of operations is the square of the number of inputs. If we check the trend, it shall be like if input is 2, perform 4 operations. If input is 4, perform 16 operations. If input is 8, then it is required to perform 64 operations. Likewise, if there are n inputs, it will take n square operations. Such a progression have time complexity of O of n square. Let's see one real world scenario. Imagine that you have 10 blank notebooks, each of with 10 pages. The task is to manually write the page number in each page. Also, there are 10 pages in one book. So, total number of pages in which the page number has to be written is 10 into 10, that is 100. We have to write page number in each page of 10 books, each of having 10 pages. Hence, a total of 100 pages. Here, when we see the trend, in O of n square, the number of operation equal to square of the size of task. That is, if size of task is 2, then number of operations is equal to 2 square, that is 4. If size of task is 8, then number of operation is 8 square, that is 64. Likewise, if size of task is n, then number of operations is n square. Hence, it is going a time complexity of O of n square. Let's see an example program. Here, the function check duplicates is used to check whether the given array have any duplicated integer numbers. For checking this, the program has two for loops. Such a program with two loops where the inner loop is executed repeatedly for all the outer loop items have time complexity of n square. Some of the examples are bubble sort, insertion sort, selection sort, traversing a simple 2D array, etc. Here are some reference of complexities of common data structures that is commonly used in program. By checking this chart, we will be able to choose which one we need. If we are considering array, we can see that for accessing an item in an array, it takes O of 1 complexity. For searching an array, it takes O of n. Similarly for insertion, deletion, etc. Likewise, by referring to this chart, we can identify the time complexity and also space complexity is shown. Here are some references for complexities of array sorting algorithms in bigger notations. We know there exists lot of sorting algorithms. So like quicksort, merge sort, time sort, heap sort, etc. So from this chart, we can select our sorting algorithm which needs to be used in our program. Based on which is the best one, we can select the program. If you have any doubts or comments regarding this video, please share this in the comment section. Kindly subscribe to this channel. Thank you.